Welcome back to RC Pilot Hangar. Today I've got a treat for you guys. I have a good friend Dave that's going to be talking about LiPo battery maintenance and safety. So here we go, let's get started with the video.
So this evening we're going to talk about LiPo battery safety. And to start with, I have a 8-foot wingspan, 37-pound A10 that flies with 24 cells in it. I fly pattern, which uses a 10-cell setup. I fly big airplanes, little airplanes. I got all kinds of batteries. I probably have over 100 plus batteries. So the first thing about batteries, my big goal is to make sure this does not happen at my house, and hopefully I can prevent it from happening at your house. So we'll talk about that a little bit. One of the things when I start looking at LiPo safety, if you go online and you look up LiPo safety, there's some great information on the internet. But a lot of that great information is bizarrely unrealistic, and we're going to talk about that a little bit. Let's see here. Oh, and if you notice that this slide at the beginning there by the LiPo safety has a number by it. So if we're talking about something at the end of the presentation, you have a question, you know, if you can remember what slide number we're talking about or punch that number in your phone or just write it down, that'd make life easier. With that, let's get started. So we're talking about LiPo batteries this evening. All right. So this model doesn't operate on LiPo batteries. One of the things that I love, and there are two reasons I got this picture up here. One is I love this picture. It's a great picture. But the second reason I got it up there is I build some very large rocket projects, and this is powered with a 225-pound thrust rocket motor. I have a lot of large rocket motors at the house in addition to my LiPo batteries. I'm not worried about these at all. It's not going to be one of these that burns my house down. It's going to be that 3-cell, 2200 milliamp LiPo battery that's going to take my house down. Well, it takes a lot of heat and a lot of pressure to get those rocket motors started, but it doesn't take a lot to piss off a LiPo battery. And that's one of the things that we want to talk about. Again, preventing LiPo batteries and using them safely is our goal here. So we got LiPo batteries in everything today. We have it in our cell phones and our computers. You got a little neck air conditioning there. Some of my friends who don't like electric airplanes, you know, well, those LiPo batteries are dangerous, yet they have a cell phone in their pocket next to the most precious parts of their anatomy. So, you know, it's important that we know how to use these properly. All right, so just a little bit of background, and again, I don't want to bore you, and we're going to kind of put a pin in this. You have an anode and a cathode. In each of those provide a positive, negative charge, and basically that's how the battery works. And there's a very, very thin aluminum laminate material in between the two of those, and that's what separates those two. If those two things short, you get a spark. You get a spark, you get a fire. As the battery wears and as the internal part of the battery starts to break down, one of the byproducts of that is oxygen. When those elements produce oxygen, your battery starts to puff. Oxygen, as you know, is very flammable, and if you remember the Apollo 1 accident, you know what happens when you can combine oxygen with electric spark. It's not very good. All right, so just a couple warnings. This is not a complete how to prevent a fire in your house. This is a primer. This is to get you thinking about making a plan so that you can prevent a LiPo fire. I'm going to show you some of the techniques that I've used successfully. We've talked about a lot of the information on the internet. I want you to think about developing your own safety plan for LiPo batteries. They're not dangerous, but they are unforgiving to the people who want to neglect them or be ignorant. But just like gasoline or anything else you have dangerous in your house, LiPo batteries can be dangerous if you're not careful with them. A couple things, and you guys know this, but I just want to review. When you're handling your LiPo batteries, you don't want to pick them up by the wires or drag them out of the airplane by the wires. Always, this is amazing to me. I can't believe I'm telling you this, but I have to. You gotta plug the charge lead into your charger first, then plug that charge lead into the battery. When you're undoing things, unplug the battery first, then the charge leads. You won't believe how many people I've seen where it looks something like this. Don't try this at home. This is a huge no-no, having the battery plugged into the charge lead. A couple things I'm going to caution you about. Anytime you buy that new charger, you come home and say, hey man, I got this great brand new charger. This thing's great. You really need to keep an eye on it. The other thing you need to be very careful of is what you're selecting, what kind of battery you're selecting when you use that charger. So what I want to do is cover what happens from the time that we get the batteries, brand new, from the time that we have to put them in the cemetery and kill them. Okay, so we get the brand new batteries either at the hobby shop or the big brown toy truck shows up and we have these great new batteries. First thing you want to do is take them out and take a good look at them. How are they physically? Are they puffed? Is there any damage to them? Is there any problems with them? Then you want to plug in a cell checker and make sure that all the cells look good. Now, one of the things that has changed over the last few years, and it's relatively new, is that it used to be that manufacturers used to deliver their batteries with a storage charge. In other words, they had about 50% in them. So if you took them home and they sat in your shop for a year or two or three, it really didn't matter. But now, because of post office requirements, some manufacturers, I don't know that all of them are doing it or not, are shipping the batteries at an absolute minimum charge rate. The problem is if you take that battery and you stick it in your closet and you don't do anything with it, it's going to self-discharge. And when it self-discharge, one of two things can happen. One is it'll go bad, and that's a shame. Now you have this brand new battery that's trash. And when batteries go bad, they start to puff. And when they start to puff, now you have a possibility of having a fire. So it's important that when you get these brand new batteries that you take a good look at them. Storing lipos, here's where we get into fiction and fantasy. I've read on the internet that they need to be stored between 40 and 70 degrees, that you should never store them in your house. Well, I live in Texas. If I don't store the batteries in the house, they're not going to stay at the proper temperature to store batteries. So I have a choice. I can store them outside, maybe in a shed or something, where they're going to be exposed to, what we have, 10 degrees, a couple of weeks ago, and 108 degrees, 110 degrees during the summer. Now you're going to put your batteries in a position where they potentially can catch on fire because you're not storing them properly. So for me, it's not realistic to not store them in the house. But I do want to store them in an area, in a way that if something goes bad, that they're not going to burn my house down. Having said that, the major part of my plan for a safety plan for LiPo batteries is to prevent the fire in the first place. If I can prevent them from catching fire, then I don't have to worry about the ramifications of them being on fire. But I'm still aware that they can catch fire, so I'm storing them in a safe manner. And we'll talk more about that. If you drop the battery or damage the battery, and we'll get into that, kind of put a pin in that, we're going to talk about that later. Where to charge, same thing. On the internet says, oh, don't charge your batteries at home. You should be charging them outside, or should you be charging them at the field? Well, again, if it's extremely hot or extremely cold, that's not the best environment to charge your batteries in. Plus, we don't have power at the field, so I'm going to charge my batteries at home. Now, to mitigate that, I'm charging my batteries in a part of the house that if something should go bad, I'll be able to handle it. I could take a broom and just sweep that stuff straight into the fireplace. Now, it's not, the house isn't going to smell great, but, that's a way to keep from burning the house down. However, goes back to my original statement. My plan on making sure that the batteries don't catch on fire, and I'm going to back up and tell you that most of the people in here are charging the batteries incorrectly. You walk up to your charger, you plug the battery in, you hit start, you walk away from it. When the bell comes off, you unplug it. If that's what you're doing it wrong. It is very important that during the charge that you're monitoring your battery. In monitoring it two ways. One, you're seeing what the volts is. How many amps you're putting into it. Is the cell count correct? Is the resistance correct? And some of you have chargers that show that, and some may not. We're going to talk about that here in a second. But I can't emphasize enough that you monitor the charge. You make sure everything's right when you start it, and every couple of minutes you're checking the charge. In this case, when I'm charging my batteries, it's in my living room. My TV's right there, my phone's right there, my desk is right there. I'm not that far from the battery. If there's a weird noise from the charger or any weird sound, I'm right there. I'm not leaving the house. Or not leaving the house, I'm not leaving the room. I'm watching the batteries while they charge. And if you do that, and that's all you take away from tonight, that's the single most important thing. Okay, so charging batteries. Start with, that's the most common reason LiPos catch on fire is during charging. I did have a friend of mine recently tell me that a LiFi battery will catch on fire if it's charged in the LiPo setting. So first thing, make sure you're charging the right kind of battery. We already talked about most of you doing it wrong. Slow down. It's not a time to be having an argument with your wife or talking to the kids or being on the phone. Pay attention to what you're doing when you start that battery. Make sure the cell count's correct, the amps are correct, everything looks good while you're charging. And again, about a 1C charge for most of you, and monitor the charge. Okay, indications of issues. Hey, charge your battery. Battery's charging, hey dude, let's go get a beer. Not a good idea. Again, things could look good at the start. You walk away from it, things go bad to worse. Okay? It's not what you want to be picking off of your security camera in your shop. Okay, so monitoring the charge, what does that really mean? So it's kind of hard to see here, but as this battery's plugged in, all these voltages look very, very similar. They're 387, whatever. They're within a thousandth of a volt of each other, or a hundredth of a volt of each other while they're charging. And that's looking pretty good. So that's what's happening when I start the batteries. You can see here that on my charger, it shows resistance. So I can scroll down and see what the resistance is on my batteries while I'm charging. Not all chargers will do that. Some of them you have to go to a separate menu, or you actually just do a resistance check on the battery before you charge it or after you charge it, and that's fine too. But notice in my case, I can monitor the resistance as well. So let's talk about resistance for a little bit. What's the proper resistance on a battery? Can anybody tell me? And the reason is every battery is different. Every size battery is different. The larger the battery, the lower the resistance. So if you have a 5,000 milliamp battery, the resistance on that's going to be a heck of a lot different than a 500 milliamp battery. But what you are looking at in resistance, and it's also, let me step back for a second. It's also, if I have two 5,000 milliamp 6-cell batteries in my hands, and one has a 1.5 ohm resistance, and the other one has a 3 ohm resistance, is a 3 ohm one worse than the 1.5? Not necessarily, because again, you're pulling a lot of current through it. So you're only looking at the resistance at one level. Doesn't mean that at 80 amps, that's what the resistance is. So having said that, what I am looking at resistance is for a change in resistance. Are the resistances on each of the cells similar? Not only that, as I run that battery, is that resistance starting to change, particularly if it's starting to get greater. What I normally find is on new batteries are a little higher. As they start to break in, they come lower, and that's where they sit. And as they start to die, I see them resistance slowly coming up. So it's a relative thing. Okay. So many of you probably use these Lipo bags to store batteries or to charge batteries. They're great for transporting batteries to the field, bringing them home from the field, but they're not going to prevent your house from burning down. One of the problems about using a Lipo bag while you're charging the battery is you can't see it. You can't feel it. Is that battery getting warm? Is it starting to puff? If it's in that bag, you're not going to be able to see these things. Also, being confident that bag's not going to set your house on fire is not a good plan. Again, looking at the battery, you can see this one's starting to puff a little bit. Why is it puffing? Can anybody tell me why this battery's puffing? Yeah, it's developing oxygen. Good, I'm thrilled. Y'all are paying attention, look at that. If it's puffing more like this, that's even worse. About this time, I can honestly say this battery looks like it's not good for me. So puff batteries, I want to talk about puff batteries for a second. So going back to some of the early examples there, you saw just a little bit of puffing. Is that battery bad? Not necessarily, but now it's something I really do want to keep my eye on. Really keep my eye on during charge and after the end of a flight. Take a look, I pull that battery out, is it puffed even more? So, it's giving you those signs that, hey, you need to be paying attention to this battery. Resistance, okay, we already kind of talked about resistance in a lot of detail, but what if you don't have, what if your charger doesn't show resistance? How do you determine what the resistance is? Or if I have a problem with resistance in the batteries, and one of the first things you can do when you're charging that battery, if you put that battery on and you have it sitting there at 3.8 volts per cell or 3.85 volts per cell or somewhere in there, and you plug in that battery and you start that 1C charge and all of a sudden it jumps up to 3.95, you probably have, that battery's starting to develop some serious resistance. I plug batteries in and they boom, all of a sudden they're 4.0 volts. And then they do the opposite. If I put it on discharge at 1C, when they're fully charged, all of a sudden they go from 4.2 volts and all of a sudden I'm dragging it down to 3.8 volts. That's a high resistance battery. And it's telling me two things. One, I probably don't want to fly it, but more importantly is that battery's getting ready to go south on me and could cause a fire. Another thing I'd take a look at is it, am I getting 80% out of that battery? And typically, I don't do this with great frequency, but a lot of the time what I'll do, I have 3.2 volts there, which is at the absolute minimum. But a lot of times I'll fully charge a battery, and then I'll put it in the discharge mode down to about 3.6 volts per cell. And I'm expecting to see at least 80% of the rating of that battery back. It's a 5,000 milliamp battery. I better see 4,000 milliamps back out of it when I do my discharge. If not, it's time to get rid of it. So what's a bad battery look like? And apologize for the lack of precision of this, but in this example, you can see that these are all 3.9 volts. It's only been on the charger for 42 seconds. I have a 4.5 resistance in this cell, 3.9 there. That's not bad, but wait a second. I got a 7.4 there. Is that terrible? It's a relative thing. I don't know, but let's see what happens. Continue this same discharge, or same charge, I'm sorry. And again, you can see the voltage coming up, 3.92, 3.918, very similar, everything looking there. But now all of a sudden I'm 4, 3.9, those two look good, but I'm up to 8.4 on that one odd cell. That's not good. But let's see what happens. Leave it there on there a little bit longer. We're now 1 minute and 31 seconds into the charge. I'm 9.7 on that one cell, where the other two cells are holding steadily very, very close to 4 volts. And then as I continue that charge, finally, 1 minute 44 seconds into the charge, you can see that that bad cell's gone up to 12 ohms resistance. So again, if like in that example I showed you, if I decide it's time to walk out of the room, grab a beer, what do you think is going to happen to this battery? Now, this is a good charger, and hopefully that charger is going to detect something's bad and, stop the charge. But you want to keep an eye on it. Monitor the charge. So many of these chargers, particularly the more moderately priced ones, all come with the same software. And I've seen some changes in recent years on these chargers. So you turn the charger on, and the first thing it does is what kind of battery you're going to charge, and typically Lipo is the default, and that's a good place to start. You hit the button again to charge the battery, and the first thing that comes up, it's Lipo charge. Can everybody see that it says on the screen there, Lipo charge? Is that where I want to charge the battery? No, but that's the first thing it offers me. This is not a balanced charge. This is just if I'm charging a 3-cell battery, this is looking at it as the battery as being one thing. So it's not going to charge the individual cells the way a LiPo battery needs to be charged. So you have to hit that button again to go to the LiPo balance mode. So particularly for beginners, if you're working with somebody that's new to with this, remind them that they need to be in the LiPo balance mode in these, not necessarily the LiPo charge mode, which is the first mode that's offered. So by default, it's leading you down a path which is going to create issues. May not do it on the first, second, third, fourth charge, but you keep charging the battery like that, eventually one of those cells is going to get out of whack and it's going to get you in trouble. A few other modes, they have fast charge. That's something I personally never use. LiPo storage, everybody I hope is doing this. You go home at the end of the day, you check your cell voltages. By the way, a lot of the time I'm almost exactly where I want to be in LiPo storage when I'm done flying, because I'm very conservative on my batteries. But you can put them on here and they'll bring it up to 3.8. So let's talk about where should I be when I store a battery? You want it between 3.75 and 3.85 volts per cell. Now, a lot of these chargers default at 3.8. Typically, I store at 3.85 on the chargers that I can select something, because they will lose just a little bit of current each month. It's not like a NiCad battery or a lead acid battery, but it will lose a couple %. So if for some reason I don't ignore a battery for a long period of time at 3.85, it gives me a little more time before that battery goes south. However, having said that, it's also at the very high end of where a storage charge should be. So maybe it wouldn't last quite as long as it would be in terms of years for 3.8 volt per cell battery. Having said that, the batteries I were flying yesterday and the day before in my Chaos, the 6-cell batteries, are now 9 years old. And I have probably a couple hundred cycles on each of those. Okay, these chargers, the same software that's on a lot of these moderate price chargers, also offer a discharge mode, which works very well. The problem is if you walk away, it knocks the battery down to 3 volts per cell. at that point, you've probably killed your battery. So if you're going to use this discharge mode, that's fine, but just monitor the cell voltages, and when it gets to wherever you want it, stop the discharge. Don't let the charger stop the discharge, because by then you've probably ruined your battery. Maintenance. Every 6 months, it takes me 2 days to do this because I have so many batteries. You got to check your batteries. Plug a cell checker in there and make sure all the batteries are about where you want them. If they're starting to sag down, what I'll typically do is I'll charge it up, discharge it, put it back on a storage charge, put the battery back away. Because they're about, with all those batteries and all the different airplanes I have, I don't get to fly them all the time. It may be a year or 2 or 3 before I get to fly an individual airplane. In the process of that, one of the mistakes I've made in the past is that includes your transmitters, that includes the receivers in your glow or gas airplanes or sailplanes. A lot of the time I'm using LiPo batteries to power the electronics, and I can't neglect those airplanes. I mean, I have a few RC airplanes, I gotta admit, and I assume that y'all do too. And occasionally somebody say, well, how many airplanes you have? I can't answer that question. Going back to talking about exactly those things, I don't know how many airplanes I have. One of the mistakes I personally made, I go to events and I win something in a raffle or something like that, or somebody gives me an airplane, and all these bind and fly airplanes have batteries in them. Don't ignore these airplanes, which perhaps everything that's on that table, I've never flown. And they sat for years, 2 or 3 years. I finally opened up, figure I need to be looking at these batteries. I look them up, and the batteries, most of them, they were all almost dead, and some of them were getting puffed to a very dangerous level. So don't forget the stuff that somebody gives you that's got a battery in it. Somebody, a very good friend of mine, moved out of town, gave me a Hangar 9 D-Night Special, really cool airplane. And in that, he had a 1600 milliamp battery for the radio. He had a 6000 milliamp battery or a 5006 cell in it for the airplane, and I looked, check that battery. That battery's great. But I went to look at the battery for the electronics. It was scary. I literally got rid of it that night. So, keep that in mind. This doesn't happen to anybody in here, does it? Nobody, none of you guys this happens to, I'm sure. But bad things do happen to the best of us. Every airplane has a expiration date. You just don't know when it is. Remember when we looked at one of those first slides and we talked about how a LiPo battery is put together? It's got those thin sheets in between that separate the positive and the negative. Well, here's the problem, is that when you damage that battery, you're squishing all that together, and you have a very high opportunity to short one of those cells. And I literally, years ago, a friend of mine had this neat little Delta Wing airplane. It was had a little 65 millimeter fan on it, and this thing went like stick. It went like 200 miles an hour, and this thing was way out of trim. And I was trying to test fly the thing, and I was pulling the stick down to the left and pulling up and hanging onto this thing for dear life. And the guy that owned the airplane sitting there trying to move the trims, and somehow he managed to move the switch off on the transmitter. And it didn't end well. So we go over and we collect the pieces and we put it in the car, and we're kind of talking what happened when we're looking at the transmitter, and I hear this noise from his airplane in a little bit of a hissing sound, and I grabbed that battery by the lead and threw it out on the street, and the battery burst into flame. And that was probably a good 5-6 minutes after that airplane hit the ground. So anytime we drop a battery or we have a battery involved in a crash, you want to get that battery in a safe place. Probably at our field, it's where there's no grass, maybe out on the Caliche Road out there, somewhere somebody's not going to run over it, somewhere where if the battery bursts into flame, it's not going to do any damage. Certainly not in your car. I would highly recommend that you don't put damaged batteries in the trash can out there. You need to take them home and deal with them, but anytime that you have a damaged battery, treat it like it's going to catch on fire. You can see this one going from not so bad to horrible at the end of it. In the sequence of pictures, I can't tell you how long that was, but I can tell you I was very surprised by that experience when we did wreck the battery. So when I have a damaged battery, be ready to drop it or whatever at any minute, because it could go bad. I do plug a cell checker into it, and if one cell really is way off, it's way, if all the cells are good, but one's like 2.7 or 2.2 volts per cell, that battery's getting ready to go south on you. So be very careful with it. So, and that's kind of where that LiPo bag is helpful if you're going to transport a damaged battery home.
Is that just for visibly, physically damaged batteries?
Visibly, physically damaged batteries. Okay. So again, check the cell voltages, put it in a safe place, monitor it for about an hour. And if that battery is damaged and everything looks good and you decide to continue to use it, just understand that, that's something that should keep the hair up on the back of your neck and be very, very cautious with that battery. The most conservative thing to do would be to dispose of that battery. Anybody bring marshmallows for this? How bad of a fire? It depends on a number of things. The charge state of the battery is going to determine how bad the fire is. A fully charged battery is going to be a lot worse than something that's practically dead. If there are no volts in it, it's not going to catch fire unless you light it with a match or something. Obviously, what's flammable around it is going to make a big difference as well. But it's going to depend on the size of the battery and the charge state of the battery. So how do we get rid of a battery that we don't want anymore? It's either served us well for like these batteries have for 9 years, or we damaged it. How do we get rid of it? So this is the procedure that I use that's worked very, very well for me. But again, and I'm glad I'm having the opportunity to do this time of year while it's still cool outside, because when it gets hot outside, this becomes a more risky operation. So I use my discharger on my charger to get that charge voltage down as much as possible. I have an old Astroflight charger, which is really kind of cool because it's not looking at individual cells at all. So I can discharge my 6-cell battery and then fool it thinking it's a 5-cell battery, and then fool it and thinking it's a 4-cell battery, and I can get a good head start on discharging those batteries. And then the next thing I do is I get a 24 volt light bulb. And you go, well, where am I going to get one of those? Amazon. All your general aviation airplanes built from the mid-70s on have a 28 volt with a 24 volt battery electrical system. So the lights in all those all run off of 24 to 28 volts. So get yourself a battery, solder it up to a connector, and then I can plug that into my battery outside, away from the house, as a kill device. Because when I kill that battery, it's going to get warm and it may puff. So I want to do this in a place that, again, I can accept the fire if it happens. And I leave that light bulb in there till it goes dead, and an hour later. I've also used I've taken some small electric DC motors, put a connector in it, plug that straight in the battery and let that DC motor run. So you want something that's not a heavy load, but a light load, and enough load to completely kill that battery down to nothing. Okay? Now, by the time you get it down to nothing, I check it with a voltmeter and make sure that there's nothing going on. I will clip the leads, very carefully touch the 2 leads together. I'll check with a voltmeter, make sure it's literally nothing. Run the 2 leads together, make sure there's not a problem. Then I'll twist those leads together, tighten them up, put a drop of solder on them. And now they're, again, I'll leave them outside for several hours before I bring them in the house. But now they're safe to dispose of. They're not going to just instantly burst into flame and create a LiPo fire. That doesn't mean that they're not flammable if you threw them in a fire, but certainly they're at this point they're pretty much inert. It's a great way to do it. Now, some people use salt water or put them in a bucket with sand, and all that stuff's good, but this is really how you can kill them. That's just showing my setup. Again, that final discharge of the battery with that light bulb plugged in. And I have adapters. I can adapt that light bulb to any battery I have. Finishing the job, you can see that the leads have been cut, the leads are twisted together and soldered. Best practices. So when I first put this presentation together years ago, at a pattern contest, I took this picture of one of the contestants' back of his car, and he had this really neat system where he has a large power supply in there, and he can plug in, and he's got his inverter and his charger and his batteries all right there in the back of his car. And I took the picture, and he said, why are you taking the picture? I said, I'm doing a presentation on LiPo battery safety. And he paused, and he said, you're showing this as an example of what not to do. And I said, that's right. So, this is not a good idea to be charging batteries inside your car. I don't recommend that for a number of reasons. It's not going to get the cooling air, and of course, if something goes south, unless you're sitting there next to that battery, you could lose your car. Okay, in conclusion, just take a look at that. The top, monitor your batteries during the charging process. Of course, treat your batteries with all safety issues in mind. Monitor your batteries during the charging process. Check your batteries every 6 months. Take your time to dispose of the batteries responsibly. And the last thing I can tell you is monitor your batteries during the charging process. Don't walk away from them. Any questions? Sam?
24-volt DC light bulb, or it does make a difference?
Well, like your car is the same thing. Your car battery is 24 or it's 12 volts DC. The alternator puts out AC, but what's really supplying is the 14 volts DC to charge your battery and do all that stuff. So all these airplanes, unless you get into a Gulfstream, all these general aviation airplanes are DC airplanes.
So it's a DC bulb.
It's a DC bulb. Yes, sir.
I've been storing my Lipo batteries in that bag that I bought that I was told was a fire-safe bag.
You saw the picture of the flame shooting out of the bag in the.
Well, yeah, so do you recommend like a metal ammo can or something?
Yes, but so a metal ammo can's good. So I have metal ammo cans that were under the flap. I've drilled holes so they can vent. So what you don't want to do is you don't want to put the battery in something that can't vent, because otherwise you're now creating that as an explosive. So if you put it in a metal ammo can and you snap the lid down and you hadn't drilled holes under the flap so it can vent, now you're making a bomb, because now as the battery vents, that can's going to expand to the point that it can't hold it anymore and it's going to explode. I also use fire safe boxes that have a lid that lock, but I leave the lid open so that the lid, which is relatively heavy, can lift and vent as opposed to the box going boom. Now, I also store batteries in the Lipo bags just like you have, but those Lipo bags go in a fire safe cabinet. So it's in the bag in the fire safe cabinet.
Do they sell those at the hobby stores?
Ammo cans?
Well,
Get them at Harbor Freight.
Harbor Freight, yeah.
Harbor Freight's got them and they're fairly cheap.
Yeah.
Harbor Freight, I know what that is. And look for, what do I ask for there?
An ammo can.
Ammo cans.
Metal ammo
They're
can.
on the west side of the store. There's the store in Denton. They're on the wall
Yeah.
on the west side of the store.
Yeah, and I do use the Lipo bags just for that increased security going back and forth to the field and stuff, or if I wreck a battery. But again, I appreciate the fact that that Lipo bag is not going to prevent my toolbox, my house, my car from catching on fire. It'll limit it, but it's not the catch-all, end-all that they advertise them to be.
Okay, but you also said if you snap the lid shut and it doesn't vent, that's not good either. So you gotta have the ammo can.
Got
And-
a hole at the top.
So the ammo can has flaps that go over the sides of it. At the top, the flap is maybe an inch deep. So above that flap, I'm drilling holes. So it can still vent, it can still breathe. But I'm not just snapping the lid on the ammo can and leaving it airtight, because that, yeah.
On my ammo cans, they've got dimples in the top from spot welding. It's perfect for drill start. I got like 8 holes in the top of it.
Yeah, whatever you do, you don't want it to be airtight in something that can hold it really well, like an ammo can. You want something that's easily, like I said, I have these fireproof safes that I put things in, and the lid maybe weighs, a pound or so. And if it should start to vent, it'd be, the lid's not locked. It can lift that lid up a little bit and vent, as opposed to building up pressure in there to the point that something bad happens.
As far as disposal goes, I don't know about other cities. I'm sure everybody's got the same thing. The city of Denton has a place where you can take hazardous materials. You can take paint cans there. They have a drive-through and just drop off anything like that. I give them my Lipo batteries, and they gladly take them. I don't know what they're doing with them.
Right.
But honestly, I'm done with them at that point.
Right, and the responsible thing is to make sure that they're inert when you do give it to them, that they're not going to start a fire in their hazardous disposal. So
Batteries plus will take them if they're not puffed up. They'll dispose of them.
Careful about that.
there you go.
They charge you by the pound.
Really?
Yep, I took a bunch over, it cost me $130.
Oh, my God.
I asked the guy to take it, and he said no, because it was fucked up, we didn't get
Oh.
it. But
All right.
thank you.
I bet your city will take them from you.
Yeah, they will. Charge, I found in Amazon, a charger. It's like to kill the battery.
There you go.
It's a LED and there's a XT80, what's the,
Whatever.
and so it's for Lipo and there's a LED. When the LED goes off, like that thing's,
It's okay. Same thing. So it's discharging it down to 0. Yeah, and that's what you have to do to kill it.
like start first because it's a lot of voltage for that thing.
Right.
If you twist those leads together, it's better in Dillinger.
Right. Well, and that's all, that's the whole thing. So like I said, I put it on the discharge, let that, like I said, when the light goes out, I leave it for another hour or so, and then you may have some little bit of residual. So, make sure that when one, I'll check with the voltmeter, but I'll still gently touch the wires together before I put them together solidly and twist them and put a little solder there. That's the night, your opportunity to do a really bad solder job is just, it's just enough solder on there to hold it together. Any other questions?
Yeah, I wanted to ask you, a Spectrum transmitter, it has a LiPo battery in a hard case.
Right,
And it's just got the wall wart charger with the,
right.
what they call a connector on it.
Yeah.
But it's, there's no balance plug, there's no nothing on it. I plug it in, I take it out. Is there anything I can do to make sure that the transmitter batteries are being treated well?
All right, so, and that's an excellent question. So, because like you, many of us have those Spectrum transmitters. So at the point that you find that your battery is not lasting as long as you should, you charge it all the way up, and you used to get, God, those batteries literally last 100 flights. I mean, they last a long time. And all of a sudden, the voltages are going way down. It's time to replace that battery before you have to replace the airplane.
Okay.
And then the same thing, you just have to kill it the same way. You'd have to, hook it to some kind of kill device to kill it all the way down. And
But there's no balancing, no.
there's not a lot you can do about that.
Yeah, there's on some of the batteries that the transmitter especially, they'll have it written right on there. Balancing function is inside
Right.
the case of the battery, so you don't
Okay.
have to worry about it.
Well, in the other,
Again, it
right. Yeah, the other issue that comes up is the greater the cell count, the more important it is to have them balanced. So if you have a 2-cell battery, and actually I got some transmitters, believe it or not, run on a 1-cell battery, there is no balancing. But yeah, good point.
I wasn't overly concerned, but it's just completely different from everything else.
Well, and again, when you go home, please not only check your flight packs, but think about all the airplanes that you have LiPo batteries to power the electronics in your airplane. You may be flying a gasser, but you have a LiPo battery for the radio, and you have a LiPo battery for the ignition system. And then all those bind and fly airplanes that you either won at a raffle or you picked up someplace or somebody gave you, open those lids up and see what those batteries look like. But again, my philosophy is to try and prevent that accident from happening. Charge them in a place that makes sense in your house, that if something goes bad, that you have a plan to react to it. Do store your batteries. One of the pattern flyers, he has a very nice garage that's separate from his house. So he decided he's going to put his batteries in there, which was not a terrible plan. The problem was it wasn't environmentally controlled. And while I'm getting several hundred flights out of my batteries, he's wondering why he's only getting 30 or 40. And that was part of the problem.
What I did is I bought a wine cooler.
A what?
A wine cooler
There you go.
that'll store at 65 degrees, and I keep all my batteries in there.
Well, and that works great. The other side of the coin is make sure you don't freeze your batteries. They don't like,
Good idea.
they don't like to be frozen. Yeah, if you have a shed that's powered, that's not part of your house, that's excellent. That's the ideal situation right there.
Yeah.
But not all of us have that capability.
Thanks. I'm going to send my wife to talk to you.
I think I paid $50 for it. So.
There you go. There you go. All right. Well, thank you for your attention. If I have helped prevent one of your homes from looking like that first picture we saw, I've done my job tonight.